Welcome back, everybody. Today we're going to talk section 4.2, Rolle's theorem and the mean value theorem. All right, we learned in the last video, the extreme value theorem states that a continuous function on a closed interval, AB, must have both a max and a min on that interval, right? If it's a closed interval, there must be a max and a min. However, the max and the min could be at the endpoints, right? Rolle's theorem named after French mathematician Michel Rolle gives conditions that guarantee the existence of an extreme value on the interior of a closed interval. All right. So basically, Rolle's theorem is kind of what we call an existence theorem. It basically will give the conditions that will guarantee you that your max or your min on that closed interval won't be at the endpoints. It'll be inside that interval. All right. So what it says is that if is continuous at every point on the closed interval AB, scroll up, I need more room, and differentiable at every point in its interior it's a bad parenthesis. I'll do a better one. AB, right? If f of A equals f of B, then there is at least one number C in AB at which f prime of C equals 0. So that is Rolle's theorem, basically saying that if it's differentiable at every point in the interior and f of A equals f of B, then there has to be some point where you have your max or your min. I'm going to do a quick picture. There's A and B. And so they're equal, right? So this is equal to that. So those are equal. What it's saying is that there's some point C where f prime of C equals 0, and you get that horizontal tangent line. Now you might say, hey, well, that's a perfectly drawn figure. Let's draw another example. Another example would be something like this. So as long as A and B are equal, now they have to be equal, right? So the conditions are A and B have to be equal, and it has to be differentiable, which means no corners. It has to be continuous. So, and we can see here there are multiple spots where we would have a max or a min. All right. So here's an example that will further illustrate Rolle's theorem. If we let x, or f of x, sorry, f of x equal x to the fourth minus 2x squared. We're going to find all values of c. C in the interval -2, 2, such that f prime of c equals 0. So basically what it's saying is that I want to find out where inside this interval, so inside this interval here, I can have my derivative equaling 0. All right, well, the first thing we need to do is we need to make sure that this satisfies Rolle's theorem. So I need to know what f of -2 equals and what f of 2 equals. So at this point, I'm going to ask you to pause the video, and I want you to figure out what f of -2 is, what f of 2 is. Now remember, for Rolle's theorem, they have to be equal. So if they're not equal, we can't use Rolle's theorem. If they are equal, we can move forward. So figure out what they both equal. I'll be right back. All right, so I got -2 to the fourth minus 2 times -2 squared. All right, and I got that equaling 8. Make sure you got the same thing. For f of 2, I've got 2 to the fourth minus 2 times 2 squared. And we know that the negative, right, that it's going to equal 8 as well. So basically what we're saying is that we know Rolle's theorem applies because our endpoints are equal, right? Our y values for our endpoints are equal. So we know there's at least one value where the derivative equals 0. Well, the first thing I need to do is I need to find out what my derivative is. So I'm going to keep that on the screen. I'll use the power rule. It's 4x cubed minus 4x. I'm going to set that equal to 0. And now I'm going to solve it. All right. So why don't you guys do a little bit of algebra first? See if you can solve it. And we'll compare our answers on the back end. All right, so I can factor out a 4x. I'm left with x squared minus 1 equals 0. So I got 4x equals 0, x equals 0, x squared minus 1 equals 0. Can factor it, and I get x equals -1, x, equals 1. All right, so all three of these values are within my interval. Notice my interval is from -2 to +2, yes? So all three of those are places where the derivative is going to equal 0. So basically for this problem, I have 3 answers. All right, Now, the interesting thing with Rolle's theorem is it can be used to prove another theorem, the mean value theorem. Now, I'm not going to go through and prove the mean value theorem. I'm just going to tell you what it is. But if you were to prove it, I would use Rolle's theorem to do so. All right, so what the mean value theorem says is if f is continuous on a closed interval, AB, and differentiable on the open interval. AB, then there exists a number C. Such that f prime of C equals f of B minus f of A over B minus A. All right, so basically it's saying we can find that. All right, so let's try an example. All right, so let's see. Let's try an example real quick. So we have given f of x equals 5 minus 4 over x. Find all values of C in the open interval (1, 4) such that f prime of C equals, and now I can use my open interval because this is B and this is A, so I can say f prime of C equals f of 4 minus f of 1 over 4 minus 1. All right, so what are we going to do? All right, so this looks to me like the slope formula, yes? So let's evaluate that slope. So f of 4 is 5 minus 4 over 4. 5 minus 4 is 4, right? Minus f of 1. If I plug in 1 for x, I get 5 minus 4 over 1, which is 5 minus 4, which equals 1. So that's 4 minus 1 is 3 over 4 minus 1, so that equals actually 1. So my slope equals 1. All right. Now, because my slope equals 1, right, and f fulfills the conditions of the mean value theorem, there at least exists one number, C, such that f prime of C is going to equal our slope, right? Because our derivative is slope. So let's do the derivative of our original function. Our original function is 5 minus 4 over x. All right, so our original function, 5 minus 4x to the negative 1. I'd rather write it this way because I'd like to use the power rule if I could. So f prime of x equals what? So why don't you pause the video now, execute the derivative, simplify it, and we'll compare our answers on the back end. All right, so if you use the power rule and then simplify, I got 4 over x squared, and we know that equals 1. Now the question is, what value of x could I put in there to make it equal 1? Well, just by looking at it, I can say x could equal -2 or x could equal 2. Now the question is, do we have two answers like we had, multiple answers for the last one? Well, let's look back at our interval. Our interval is from 1 to 4, and one of these is in between 1 and 4. The other one is not. So if it's not in your interval, we can't use that number. So the answer is x equals 2. All right, let's try one more applied example. All right, 2 police cars equipped with radar are 5 miles apart on the highway. As a truck passes the first police car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove the truck must have exceeded the speed limit of 55 miles per hour at some point during the 4 minutes. All right, so how are we going to do that? Well, let's draw a picture first. So here's the first police car. There's the second police car. And at the first police car, we'll say that's time equals 0. And at the second police car, we'll call that, if we're going to do time in hours, right, because it's miles per hour, so I want my time in hours, I'm going to take my 4 minutes divided by 60 and get 1/15 of an hour. Does that make sense to everybody? Because if I'm going in miles per hour, I want my time to be in hours, not minutes. That way everything is a similar type label. All right, so if we were to get average velocity, remember average velocity is slope. So our average velocity is, right, I'm going to do my function at my f of b minus f of a over, excuse me. All right, now the key is here, I don't have a function, right? I don't have any function s. I'm just using s as a position function, right? But there is no function in our problem. However, I do know that if I'm starting at 0, right, by the time I get to the second police car, where am I at? I'm at 5, yes? So my position at 1/15 of an hour was 5. So even though I don't have a function, the clue was hidden in the problem. So this is going to be 5, right? Now remember, right, at the original point, right, I haven't gone anywhere. So that's 0 over 1/15 of an hour minus RT equals 0. So that's 5 over 1/15, right? And that would equal 75. And that 75 is indeed miles per hour because we were looking for average velocity. Right? Now, we do have to assume that S is differentiable. Right? We have to assume that there's no hard corners on this road, that it's just a single road, right? We didn't, right? 2 stationary apart on a highway, right? It's kind of understood that a highway doesn't have any really sharp corners on it, and most indeed is continuous. So we have to assume S is differentiable. If we do, we can apply the mean value theorem to conclude that the truck at some point must have been going 75 miles per hour on that interval. All right. So to conclude this problem, you'd say, assuming S is differentiable, you can apply the mean value theorem. MVT is an accepted abbreviation for mean value theorem to conclude that the truck, 75 miles per hour at some point in the interval. Right? Because the mean value theorem says at some point in that interval, you're going to be going the slope, right? And the slope here was 75. So there is your quick exposure to Rolle's value theorem, mean value theorem. I would say I'd be pretty comfortable to say that you might have one question tops on your exam regarding this. You would most likely definitely have at least one question on a quiz regarding this. Probably more of a word problem than just a straight computation thing. So definitely look things over, definitely do more practice. Thanks for listening, and I'll see you guys next time.